All right. Do what? No. This is going on page 23. I wish I did. Page 23 when we're done. Okay, so finding limits algebraically. We did do this at the end of last year. We factored some stuff and canceled some stuff out. We rationalized things and did that to do some of it algebraically. If you see a limit of a rational function, which rational means you got variables in the numerator or in the denominator, and maybe in the numerator, but most of the time, then you are going to start off by trying to substitute in what you're, trying to do it by substitution. Well, what happens when we substitute the 2 in? It's 0, and that's a bad thing, right? So what you're really going to do is you're going to take the limit of the numerator and the limit of the denominator, but not as a fraction. And I'm going to show you why in just a second. So we're going to split this up. We're going to find the limit as x approaches 2 of 2x plus 5. So when I just substitute that in, I'm going to get 9. Okay? Then I'm going to take the limit as x approaches 2 of x minus 2, and that equals 0. So we find the limits independently, okay? And that's one of the things that has to be shown in your work, right? That's one of the things that College Board's looking for. Like, you found this is the value, you found this is the value. And so the limit of this is just this limit over this limit, so I have 9 over 0. 9 over 0 is undefined, right? So that's not really a number. So my answer is does not exist. Okay? Oh, you're so silly. What am I missing out on? What's so funny? I didn't know limits were this funny. Okay. All right. So now let's look at this second one. We're going to take the limit as x approaches 1/2 of the numerator, which is 2x squared plus 5x minus 3. I'm about to answer that question for you. I promise you. That is a very good question. Why couldn't we just do that and know that? And there are going to be times where sometimes you're going to have to actually write all this out, and sometimes you're going to be able to tell what's going on here, but I'm about to show you the difference. That is a very good question. So when I substitute this 1/2 in, so 1/2 squared is 1/4 times 2 is 1/2, right? Plus 5 times 1/2 is 5/2 minus 3. So when I add these two together, I get 6/2, which is 3, minus 3, which is 0, right? All right, so then I have to do the denominator. So the limit as x approaches 1/2 of 2x minus 1, well, 1/2 times 2 is 1 minus 1 is 0. So when I put this limit over this limit, I get 0 over 0. Here's the answer to your question, Lorenzo. This is different than this. And so we have to decide between the two. This is what, and so this, here's the reason why you have to have it separate. I want to see that you found that this equals to 0, this equals to 0. This, again, I'm going to kind of mark it out. This is what is called an indeterminate term. I'm not sure I'm spelling it right. That sounds good. It may be a little bit wrong, but this isn't an English class. It's fine. Indeterminate. That's how you say it, Elise. Indeterminate form. And I'm going to explain to you the difference. Yes, and we are. And this is how you know whether, so my answer, even though you can't divide by 0 in either one of these, this does not exist. This one is an indeterminate form. It's not, it's a different, kind of a different form of does not exist. And here's the difference between these two. If I said that 9 over 0 equals n, right? So then I've got 0 times n, and so I have 9 equals 0n. Is there an n that could possibly be true for? What number can you multiply by 0 to get 9? Nothing, right? That's why it's undefined. It doesn't exist, basically. You with me? It does not exist. If I do 0 over 0 equals n, and then I multiply both sides by the denominator, and I get 0 equals 0n, well, any number times 0 is 0, right? So there is a value, bless you, n could be a specific value. Do you know what value it could be? No, we can't determine it. That's why it's indeterminate. Okay? And that's the difference between those two, basically. So whether or not you really understand the whys behind it, here's the thing. If you get a number divided by 0, it does not exist. If you get 0 over 0, we got to do something else. Okay? And right now we know what to do. In this particular case, my option is going to be to factor. Okay? Everybody with me so far? So you have to split it up, because what they really don't want to see is they don't want you to think that 0 over 0 is a value. So I have this, therefore it's indeterminate form, and I'm going to factor. Okay? And you can abbreviate that IND period. And you don't have to worry about spelling, but I wanted you to have, I probably should have looked up the real spelling before I wrote it on there. All right, so what we're going to do now then is we're going to rewrite this. Remember, your notation is important, so you have to rewrite it. I promise your hand won't fall off. And then we're going to factor. So the denominator is going to stay 2x minus 1. The numerator, you can factor by grouping, and there's nothing wrong with that. But I think some of you are going to be able to start factoring old school way like I was taught, which was kind of guess and check. So let's use some knowledge and I'll walk you through it. Since this is a prime number, I know that the beginnings have to be 2x and x. Okay? This is negative, so my signs are different. Right? So I'm not going to put them in there yet because I'm not sure which one goes with which. But I'm going to need a positive 5. So I'm going to need 2 times something and something times x, and I'm going to have to subtract them to get 5. So basically I'm going to need 6 and 1, right? So if I put 1 here, that's going to give me a 2, and it has to multiply to give me 3. So if I put a 1 here and a 3 here, I get a 2 and a 3, and they'd have opposite signs. So instead I'm going to put a 3 here and a 1 here. These two will multiply to give me 3, right? And then which one would have to be negative? The 1. Plus, in a question like this, do you have a pretty good guess of what one of the factors would have to be? 2x minus 1, then you can probably figure the other one out. So you can still factor by grouping, but if you practice kind of just reasoning through it and then check yourself, you'll get a little bit better at that. The numbers will kind of start to make sense. Okay, so since we're here, now that I have this, I can reduce that. This is equal to the limit as x approaches 1/2 of x plus 3. Do not put 3 1/2. You can put 3.5, you can put 7/2. But I think 7/2 is the better one myself. I mean, you can think of it as 3 1/2. You could put 3 1/2, but don't make that your final answer. 7/2 or 3.5 would be fine here. Questions on that? Okay. So we're going to skip over the next two for a minute, but we're going to just look at this next one for a second. We're going to come back and talk about it. If I look at this, I know I'm going to have a 0 in the denominator. And this one's a little bit easier to kind of look at and see, and I don't have to do a whole lot of work. I might have to write it out. But if I put 0 in here, that's going to give me the square root of 2 minus the square root of 2. So I'm going to have 0 over 0, which again is the indeterminate form. So I wouldn't put does not exist. You don't just automatically put does not exist because the denominator is 0. You got to check it. Okay? And we'll come back. We'll come back and talk about these two a little bit if we have time today. If not, we'll see what happens. All right, so let's look at these piecewise functions. Now it does say sketch the graph and then, but we're not going to sketch the graph first. We're going to talk through the limits first algebraically so that you can see how this works. We have this function, and this function exists for all x's less than 2. This function exists for all x's greater than 2. So if I am going to find the limit as x approaches 2 from the left, which of those two functions would I be using to get there? The first one, okay? So let's see if I could just substitute it in. I think I could. 2 squared is 4 minus 1 is 3. Then this exists for all the x's that are greater than 2. So that's on the right-hand side. So if I'm approaching from the right, I use this one. 2 times 3 is 6. Minus 2 is 4. So what is the limit as x approaches 2? Does not exist. Very good. And then our y, why doesn't it exist? Because they're not the same, okay? So you're right. I agree with you. I know you know what that means. So if we write an explanation, can I say because they're not the same? No. If I'm going to do that, it's okay that you said that because I know what you mean, but we're going to have the limit as x approaches 2 from the left of f of x does not equal the limit of f of x as x approaches 2 from the right. So I didn't ask you for a formal answer, so it's perfectly fine. You said they're not the same because we were just talking through it. But if you were going to write more words and something like that, be careful with the they and it and them. And, you know, you have to make sure that you are saying, you kind of have to repeat yourself on those things sometimes, okay? We good? So let's go ahead and graph this, and we're going to look at it as a graph as well. So x squared minus 1, that's just a parabola that's shifted down 1, right? When I graph piecewise functions, to me, it's easiest to go ahead and substitute this in. I know it's going to be an open circle, and it gives me the end point of the graph that I have. So when we substitute that in, we get 3. That's where that came from. So at 2, 3, I have an open circle. Then I know it's a parabola. The parent function just shifted down 1, so my vertex is here. And if x is 1, y would be 0, so it looks something like that, just to get a decent little sketch in there of the left-hand side of that. Good enough. It's just a sketch. It's not a perfect anything. So then when I substitute 2 into this one, I get 4. I've already done it, so I don't have to do it again. I have a circle there. And then I have a slope of 3, so I'd go up 3 over 1, something kind of like that. So that's a sketch of your graph. We're not trying to, make it all perfect. So we can see as you approach 2 from the left, you're getting to 3, 2 from the right, you're getting to 4, and you have that jump there, and that's why it doesn't exist. Okay? Any questions at all? Question? You have a question? You have a question? I can tell by the look on your face. It's okay. How to graph it? Okay. So you know that the graphing, that a parabola parent function is this, right at 0, 0? Okay. So if I just thinking about just the parabola and forgetting all the rest of that, all that did was shift it down right there. And then I just got those other points. To know where to stop, I just plug that in so that I know where the end of it is. Does that make sense to you? And then this is the starting point on the left-hand side, and then it's just a line, so we just go up 3 over 1. Rise over 1. Okay. Anything else? Okay. This. We've got these two pieces of a piecewise, and we want the limit as x approaches 2. Well, this is kind of like what we talked about in that question from the homework. What is f of 2? And it doesn't ask you for that, but what is f of 2? 3. F of 2 equals 3. When x is 2, y equals 3, right? This also is a parabola. But we're not going to have a point in the parabola. There's going to be a hole when x is 2. So if we were to plot that, it looks something like this, right? But then I'm going to have a hole when x is 2, somewhere right here. That. So how do I figure out what the limit is as x approaches 2? Can I substitute it into here? Yeah, because that's this point, right? And that value is actually 3, but when I substitute 2 into here, what do I get? 5. Because this is at 2, 5, and that's your limit there, okay? So you can do it algebraically, you can do it graphically, either way. What questions do you have? You'll probably have to do it one or the other. I mean, you probably have to show both ways in some form or fashion, but not necessarily both ways on all of them. Okay. Questions? All right. Okay, let's look at, flip it over. All right, so we can say that I've got rational functions. So the limit as x approaches 0 of the numerator, 5x to the 4th plus 8x squared, what's that going to equal? 0. Okay, so I have to say that it equals 0. I don't have to necessarily show that I substituted it all in. Then I'm going to do the limit as x approaches 0 of 3x to the 4th minus 16x squared. What does that equal? 0. What if this equaled 4? What would my limit be, do you think? 0. Because I'd have 0 over 4, and that is 0. So it's, But I have, this is going to give me 0 over 0, which is, we'll kind of write it, mark it out, and this is indeterminate. Therefore, I have to find another way to work it, which in this case would be what? How could can I factor here? Yeah, I can factor. So y'all go ahead and factor this one, see what you get. Yes, you have to rewrite the limit every time until you actually evaluate it. That notation is super important. Let me know if you get stuck somewhere, if you have a question. No, I'm going to say I don't think so. I will clarify on that if that is the case, because it's kind of a new word, but I wanted you to know the word and know what it is. You do kind of have to have the, oh, it's 0 over 0, and I can't do that. That makes sense. All right, we all good on that? Okay, let's look at number 2. Interesting. All right, so let f be the function defined above. Which of the following statements about f is true? So it's all about the limit as x approaches 2. So I'm thinking that we probably should find that. Probably the easiest way to work this problem, right? We know what f of 2 is. It's 1, but who cares? It's not necessarily the same. Like this could be the answer, so it doesn't mean I mark it out, but it doesn't guarantee it. So if I do this, the limit as x approaches 2 of the numerator, that's going to equal 0. And the limit as the denominator as x approaches 2 is equal to 0. So this is, we get 0 over 0, and it is the indeterminate form. Okay? So all I really care about is the first one. So the limit as x approaches 2 of x, hey. Oh, that's okay. I was getting you change. There you go. As x approaches 2 of x squared minus 4 over x minus 2, what am I going to have to do? Factor. What's going on in that numerator? It's a difference of squares. We love them. They're so easy. X plus 2 times x minus 2 over x minus 2. So I really just want the limit the limit of x plus 2 as x approaches 2. And what is that? 4. And it said true, not false, so I'm good. Always double check those things. Okay. What questions do you have? All right. So we are going to, we'll go back and talk about the ones on the front a little bit on Monday. We'll go back and talk about this last one also. Don't worry about it right now. I'm going to give you your assignment, and then I'm going to tell you to circle a couple because I want you to not worry about them right now. We'll talk about them later. So you can go ahead and tape this in on page 23. All right, so remember, if you just substitute it in from the beginning and it works, boom, you're done, okay? Circle number 7 and 8, because they go with the ones we haven't talked about yet. So 7 and 8, just don't worry about those right now. And what do you notice on the back? Oh, there's answers. That's okay. Like, if you're just one, like, I don't even want to see them yet, like, fold your paper up or something. But they're there so that you can check yourself. If you can't get those answers, we need to know. But pay attention to your notation and writing stuff out. You got this, right? Questions? We good? Look at your, I got to fold it up. I don't want to look at them.